Today we're going to present the case study of the high-rise building in Surface Pylons, the Northcliffe residences. My name is Juan Osorio. I'll be presenting the staircase system. Thank you.
My name is Ryan Wong Angus. I'll be presenting the framing part of the system. Thank you.
Hi, I'm Artin Young Yvonne. I'm going to present the core part of the wall system as well as the general construction system. Thank you.
Hello everyone, my name is Xi Yu. I will present the floor system. Thank you.
Hello everyone, my name is Ji Zhang and my English name is Grace. I'm going to present the foundation part. Thank you.
Hello everyone, my name is Lanfei Li. Today I will demonstrate the wall part, including external walls and internal walls. Thank you.
This is a PowerPoint presentation of the Northcliffe project, a case study of a high-rise residential construction on the Gold Coast. Group assignment for the subject, Commercial Construction and Engineering, Faculty of Society and Design, Bond University. This table shows all the members of the group and the key section covered by each one of them. Presentation outline. The purpose of this presentation is to report on a typical construction approach followed for the Northcliffe Residence project. This study analyzes the materials, formwork, construction method, and system used. The project details some key structural components, a general construction system, and some conclusions. Let's talk about some of the architectural features of the project. It's located on Surface Pylons Beach. It has 3 basement levels, 25 levels of apartments, 75 apartments with a selection of 1, 2, or 3 bedrooms plus medium room. It has direct access to the beach, and it has a gym, lounge, dining, steam room, sauna, pool, and terrace. Let's talk about the construction details of the project. Developer, Xinjiang Group. Architect, Coty Parker Design Studio. Builder, Hutchinson Builders, Queensland. The contract value, $111 million. It started last year, 2017. And estimated finish year is April 2019. It has a height of 90 meters. These are the key structural components we're going to talk about throughout the presentation.
My name is Lanfei Li. I take charge of wall system part. External wall is composed of pre-tensioning pre-stressed prefabricated concrete. It has many characteristics. It has high rate of early strength gain so that forms can be stripped early. It also has low long-term shrinkage so as to prevent loss of pre-stress due to shortening of concrete span. Apart from this, it has low deformation under load with time. Pre-stressing concrete also has some advantages. It has ability to achieve greater span to depth ratio than conventional concreting. It also has higher moment and shear capacity. Besides this, it has lighter and more slender members. Casting in bed formwork is used to construct the external walls. Tandem lap and anchor wedge are the components of the formwork. This diagram shows the anchor assembly process. There are 5 steps to construct the external walls. The first step is preparing the formwork bed. Next, placing the pre-stressing wire. Then fastening the anchors and stretching tandem wire on the left side. Builders should release the wire before pouring the concrete. The final step is curing concrete and cutting the penetrated wire. In regards to internal wall, it's made up of in-situ reinforced concrete. Reinforced concrete has a high compressive strength compared to other building materials. Due to the provided reinforcement, reinforced concrete can also withstand a good amount of tensile stress. Fire and weather resistance of reinforced concrete is 5. Peri-formwork is used to construct internal walls. Formwork panels are fastened by the metal couplers. Props support formwork panels on both sides. 3 steps are followed to construct internal walls. The first step is placing the panels. Formwork panels are supported by the props on both sides. Next, placing reinforcing cages into the formwork. Then pouring the concrete. After pouring the concrete, internal wall forms.
For the core, it is formed by modified concrete composition so that no additional vibration is necessary for the compaction. Instead, it is capable to compact itself only under its own weight. The Northcliffe apartment project has made use of this special concrete, which offers improved fresh concrete but also hardened material properties. The advantages of using this type of concrete for the core can be categorized into 2 performance characteristics. The first one, as shown here, is the design potential. Because of the higher early strength, the formwork can be stripped in a shorter period of time. Even though this special concrete has a rapid hardening property, it still maintains its deformability and workability after a few hours. It is able to fill all recesses and reinforcement space, which contribute to greater freedom in design and a significant improvement of the quality of the building. The second advantage is that the concrete gives a higher speed and efficiency. The faster construction can be achieved due to its rapid hardening properties, so that the fast formwork removal leading to increased productivity. The self-compacting property also reduces the on-site manpower and equipment used, which reduces the associated labor costs and the rental costs. There are 3 types of jump form that are in general use. The first one is the normal jump or climbing form. Second is the guided climbing jump form. And the one we focus in here is the self-climbing jump form system, which is also called the hydraulic jump form. The hydraulic jump form do not require a crane as they climb up rails on the building by means of hydraulic jacks. It is possible to lift multiple units in single operation. The former supports itself on the concrete cast earlier, so does not rely on support or access from other parts of the building. Generally, jump form systems comprise the form and working platforms for cleaning, fixing of the formwork, steel fixing, and concreting. As shown in the picture, the jump form starts from the basement grounds upwards. Here is the procedure of the hydraulic jump form. On your right, you can see the major component of this system. The climbing sequence begins by stripping the formwork from the previously cast lift. With the unit in a new location, the formwork is positioned and closed, and it is ready for the concrete placement to complete the construction cycle. These 2 pictures show the different sides of the core. There are 2 elevator shafts, and the other shaft is for the stair. The self-compacting concrete is a revolutionary development in concrete construction. Combining with the jump form system, they form the advanced traditional construction method, which give benefits and advantages over the conventional construction method. This is the end of the wall system. I will pass to Emily to explain more about the floor system of the Northcliffe project.
Hi, my name is Shi Yu, and now I'm going to talk about the floor system in this Northcliffe project. The floor system in this building will be presented in terms of materials, formworks, and construction methods. And first of all, let's look at the materials. There are three types of materials: post-tension concrete, traditional institute concrete, and prefabricated concrete in this building. For the post-tension concrete, they are used in the upper ground floor, which I drew in orange color, and for the traditional institute concrete, I drew black color and blue color, which are used in the ground floor and basement slabs. For prefabricated concrete, they are used in some small areas and external panels, such as balconies. And now let's move to the next part, formworks. There are three types of formworks in this building. For the upper ground floors, there are no internal formworks because of the slabs are used by the post-tension concrete. The supporting force is enough for the structure, so the formworks are only used for the external walls. For the basement levels, the formworks are built as normal and usual. There are attached beams and piles, the same as other buildings. For some particular areas and balconies, the formworks are built for the precast concrete. That means they will build some connected components to install the precast concrete slab afterwards. Now we can see three pictures. From the first picture, we can see some frames, but it is not formworks for supporting the slabs. It is just frames to separating the units in this level, because in these upper ground levels, there is no need to build supporting formworks to support the slabs. The interior walls here are not load-bearing walls, just external walls. From the second picture, we can see some extendable props that are supporting the temporary areas. While the slabs up ground levels are hardened, the formworks will be removed. From the third picture, we can see the normal frameworks for the external walls, and they haven't done the tilt slab yet. After the main slabs are done and the precasted tilt slab delivered to the site, they will install and connect the tilt slab to the main slabs. And now let's move to the next part, construction methods. The construction methods can be separated by different kinds of slabs. One is flat slab and the other is tilt slab, which will be shown in the next slide. In this whole building, most of slabs are built in flat slabs, and the main slabs are assumed to be 200 mm thick each. As we can see from the picture I circled in red color, the slab for the first floor is much thicker than the others. That's because the particular position in this building. In the ground floor, they need stronger support, so the slab for the first floor is thicker than others, so as the attached beams.
For tilt slabs are prefabricated. That means they are built in the factory with high standard machines. The sizes are universal and the same, and the concrete pressure is precise. So the tilt slabs are often used in small areas. In these buildings, the balconies and temporary use areas use tilt slabs.
And the construction method can also be separated by different types of concrete: post-tension concrete, institute concrete, and precast concrete. As it has been described before, the ground level and the upper ground levels use the post-tension concrete. This is a method that tension the concrete after the concrete is hardened. It can strengthen the concrete as much as possible. And in this building, they use the flat cable system instead of the round cable system. The next one is instant concrete. It is traditional and conventional. And the next one is precast concrete. These concretes are often used in small amounts of areas, and in this building, some small areas such as balconies use precast concrete, and they are made off-site. For formworks to slabs underground, construction methods are quite straightforward. Firstly, workers should prepare materials in pyre, including the concrete with proper pressure and tension. Secondly, skillful workers oil on concrete supporting surface to give smooth finish. Finally, they install these supporting frames to support the slab. Usually, they use acro-prop forcework. There are lots of slab formwork components to support the beam trusses. They can be extendable steel, as we can see from the picture. They are adjustable to various height, and they have lockable components, providing safe load platform. The formwork are not designed deliberately. They should take these aspects into consideration, such as dead load, life load, bursting forces, shock load from concrete placement, and after initial set. And after all this work done, the formwork should be removed.
That is the end of the floor system. Thank you for listening. And I'm more than happy to hand it to the next one to present the stair system. Thank you.
The stair system of the project. Materials used in the staircase system: permanent galvanized steel and in situ cast reinforced concrete, the formwork system, the quick stairs for the stairs itself, the speed panel for the separating wall, and the construction method is an advanced traditional system. Quick stairs is the system used by this project. It is very fast and easy to install, and doesn't require any specialized tool. It is fabricated outside of the project, then is delivered, and the reinforcement installed, according to the engineer's specification. Then the concrete is poured. It has a surface that doesn't require coating, and is ready to apply any finish when required. Some of the advantages of the quick stair system is that it's easy to order. It has a strong construction using structural rivets. The speed, because it reduces the time in construction program. It is manufactured to the PCA requirements, less propping than conventional formwork, and requires only a single concrete pour. In these two pictures, we can see the reinforcement, how it's attached to the landings. For this staircase system to be legal in Australia, it is necessary to provide a separation between the two sets of stairs. This separation must comply with the fire rating system in case of an emergency. That's why the speed panel is used, because it's an innovative shift from traditional construction alternative. It's a product ready to assemble. It is a galvanized steel surrounding a concrete core. It can be easily installed vertically or horizontally depending on the project requirements. In this slide we can see some of the properties of the speed panel. The overall width before installation is 288 millimeters, and after the installation is 250. This is because of the overlapping of the two panels once they are installed. The length is up to 9 meters and the thickness is 78 millimeters. Now let's have a look at some environmental benefits of the steel panel. It is made from raw materials of steel and concrete with a recycled content. The concrete includes 15% of fly ash, and the case contains a recycled blend of steel. It can be reused and completely recycled at the end of its life cycle. It is easy to dismantle and reassemble. This is the end of the stair system. Thank you.
The structural framing of the Northcliffe residence apartment is formed by columns and slabs. There are no beams in the framing system. The details of slabs and the concrete materials have been discussed in the flooring section of this presentation. In this session, we'll more focus on reviewing the materials, the formwork, and the construction method that are being used in the making of the columns. Steel is being used as reinforcement in the manufacturing of the precast concrete. It is a strong material that can resist heavy loads. It can help to strengthen and hold the concrete in compression. It can provide strength for the concrete against tensile force. And because of these advantages, it can help avoid compression failure and avoid buckling in precast concrete columns. The steel reinforcement is arranged into a rectangular shaped frame. The slender bars are located at the corner and on the side, and there were intermediate links tying the sidebars at every second stirrup, as shown in the figure. This rectangular framework has provided the steel reinforcement the strength to support the concrete. The formwork that is being used in the manufacturing of the precast concrete columns is the Easy Tube. They are yellow rectangular shaped strips that made of high-density polystyrene foam. They have high-strength outer layer, which is burst resistant. They also have a smooth inner layer, which allows smooth concrete surface finish. The steps of making these formworks is easy. Firstly, wrapping the strips around the reinforcement steel frame and then pour concrete into the formwork. After the concrete is settled, remove the strips. The following video will provide more details about the easy tube. The prefabrication and precast of concrete is a more modernized construction method, and because it is manufactured off-site, it has a lot of advantages over the traditional method. This construction method requires a relatively smaller amount of on-site construction operation, a smaller amount of labor, and higher productivity. The precast concrete construction method has relatively better quality than in-situ concrete method, since it is manufactured off-site and the technique used is more modernized. It is less expensive than other construction options because there are less concrete and reinforcement required in the manufacturing process. This method can shorten construction duration because the construction work is in parallel with the factory production, and the installation of the columns is faster than the traditional method. In addition to this method is less weather dependent and able to prevent any weather dependent delay. This method also offers a much more straightforward and safer construction process, which requires fewer trades on-site, less exposure to work health and safety, and industrial relation risks, less waste, and fewer materials handling.
Hello everyone, and today I'm going to talk about floating foundation in terms of material, formwork, and construction method. First, I want to talk about the foundation, floating foundation material, because this site is close to the seashore, so they use special concrete that are water chemical resistant. In order to in order to get water chemical resistant concrete admixtures are needed, such as water reducing concrete admixtures, shrinkage reducing concrete admixtures, superplasticizers, corrosion inhibiting concrete admixtures. The other material is steel that are hot dip galvanized to prevent corrosion by seared salt. In order to prevent corrosion by seared salt, proper concrete cover to prevent corrosion from external environment is needed. In terms of formwork, the timber boards as permanent formwork. So this teamwork include plywood, board, pegs, and nails. The construction steps is first excavate the soil after second piles and sheet piles walls installation. Secondly, the pegs driven into the ground at approximately 300 millimeters intervals. Third, place the pre-assembled wooden forms with the end of building rope to the correct height and line. Fourth, brace the forms strongly so they will not weaken when they are filled with concrete. Fourth, the boards are nailed on the pegs. The last step, just do the same process as the other side of the building. Now I want to talk about the construction method of floating foundation. First, pouring a layer of sand about 0.1 meter depth at the bottom of a well-aligned base. Then lay the DPC. Thirdly, bitumen fields are used for damp-proofing treatment. The next step is installation of reinforcement steel. Fifth, pour the concrete. Then we should do concrete vibration. The next step is cure the concrete slab. The last step will be test the concrete slab, which is very important. Now I wanted to talk about the basement construction. Since as we talked before, this site is close to seashore, so the basement should be soil retaining and water encasing, so we use second piles and sheet piles. So for the sheet piles, first the sheet piles are transported to the site and then they are pushed down into the soil by the crane. In terms of the formwork for basement, actually no formwork is used at this stage. Anchors and wailers are used to prevent pile wall from toppling over by lateral pressure of retained soil. And the most important thing is anchor installation. There are 5 stages process. First, drill the holes through ground to rock or sufficient friction length in soil bond. Then insert tendon strands into hole or anchor to rock. Third, use ground to fill the holes. Fifth, stress tendon after ground attains sufficient stress. Then anchor hand fitted and connected to pole wall via vellers or plates. The last thing I want to talk about is construction method of the second piles. The first step is construction of a guide wall, then installation of casing. Third, augering of primary board hole. And the fourth step is concreting of the primary borehole. And fifth is augering of secondary borehole. The sixth is installation of steel cage. Seventh is concreting of secondary borehole. Step just repetition of process, and then all the instructions are finished. That's all the construction method, material, and framework about floating foundation and basement. Thank you.
After the key structural components, I'm now going to talk about the general construction systems. There were 4 big temporary pumps situated in the slab, which formed the dewatering system for this project. It is to lower the groundwater table, since the excavation level is below the groundwater table level. The purpose of construction dewatering in excavated area not only aim at keeping the excavation bottom dry, but also a good water table stability in the groove. Normally, water treatment is necessary before it is discharged. These temporary pumps are switched off and removed once the construction reaches level 2 of the building, since there is enough weight of the building to prevent the water from coming through the slab. This picture is taken at the lowest level of the basement. However, the system hasn't finished yet. It is to make sure that construction waste is not discharged to the surface, which may contaminate the environment. A sump pump is placed at the bottom of the sump pit, which is demonstrated at the previous slides. A sump pump is installed where gravity drainage to a storm sewer is not practical. The sump pump is used to protect the basement from flooding by removing water from around the basement foundation. Groundwater around the foundation of the building is channeled through a drain system that is built around the outside of the foundation's base. Water is then thrown into the sump pit. The switch of the pump is turned on automatically when the water rises to a certain level, which pumps the water back to the surface. The automated ventilation system in the basement comprises fans and vents that is used to exhaust existing air and bring in fresh outdoor air in the basement. The main advantage of mechanical system comparing to natural system is that airflow in such system have a minimal dependency on the weather conditions. For the upper levels of the building, ventilation is provided both naturally and mechanically. We are assuming that the mechanical ventilation absorbed in the project is an apartment-based supply and exhaust air ventilation. For each level, they will have their own ducts connecting to the outdoor. Behind these doors are the car lifts that transport cars from the ground level to the basement areas. Since there are no ramps for the drawback of this high-rise residential building, parking space can be easily created in the basement of the building by using the car hoist. In order to place the concrete at the high level of construction, a high-pressure concrete pump is needed, which is mounted on a truck coming from the ground level. The diagram on the right-hand side shows the base of the pipeline that is manually attached to the outlet of the pump. The pipeline is then go to the level wherever the concrete needs to be placed. The other end of the pipe is attached to a separate placing boom, which allows the concrete to be placed over the area. All these pipelines will be removed and the holes are filled once the project is finished. The Northcliffe project makes use of a provisional lift that has a similar feature as the picture shown here. It is used to transfer workers, materials, equipment, and waste between the ground and the upper floor. The provisional hoist used in the project can take up to 2,500 kg with a maximum number of 28 passengers each time. It is driven electrically for raising and lowering relatively light loads that operate by hands. Crane is used to lift and lower relatively heavier construction materials and transporting them to other places. It is fixed to the ground on a concrete slab and is attached to the sides of the building. A fire sprinkler system is implemented throughout the whole building in order to comply with the requirements of the building regulations. The system significantly improves the safety of occupants in the event of fire. As there is quite a lot of water pressure from the water main in Surface Paradise, therefore, no water tanks are required to be installed. However, there are fire pumps located on the first floor of the building, which are connected to the public underground water supply to provide a higher pressure to the sprinkler system. That's the end of the general construction system. Thank you.